Okay, now let's look at another way here with example 3. It's called a subtle substitution. So here is the integral that I have. Dx over e to the x plus e to the negative x. Now, algebra, algebra, algebra. I can't stress that enough. Algebra is so important through calculus. Anytime you have that negative exponent, right, that tells you that you have a fraction. So I'm going to write this as 1 over e to the x plus 1 over e to the x like that. Complex fraction. Because of the plus sign, I can't just move this up with that negative here because of that plus sign. So you have to know your algebra. But with a complex fraction, I'm going to multiply everything through by this e to the x, right? So now I end up with e to the x over e to the 2x because, like bases, you add the exponents. Plus, and then that cancels out. I just have a 1. Do you see what happens? E to the x times 1. E to the x times e to the x. There's my 2x. This e to the x on top cancels out that on the bottom, and I'm just left with a 1. Now, this is very similar to the homework that you had back in whatever that was, 7.5 or 6 with the inverse trig. And I have e to the x, so use it. This is my subtle substitution. U is equal to e to the x. So du is also e to the x because remember how I told you e to the x doesn't go away? Guess what? It's back again. E to the x natural log there all the time. So I'm going to scoot this up a little bit. I am now integrating 1 over u squared plus 1 du. And what does that look like? Yes, you have to know those patterns. You have to know those patterns. I cannot do a u sub again, right? Because it's, what am I trying to say? I have a u squared down here. There's no u up front, so there would be no u sub associated with that, but it is that tangent pattern. So I'm looking at my inverse tangent. So x here is equal to this u, and a is equal to 1, right? So I have 1 over 1 in front. That's not anything. Inverse tangent of u over 1, so that's just u plus c, and then sub that back in. Inverse tangent here of e to the x plus c. Got it? And that e to the x, I mean, yeah, but that's already positive, so if you don't put the parentheses or the, whatever those are called, absolute values around there, that's fine. You can just leave that as your answer. All right, so moral of this story, things to look for. If you have this negative exponent, that's a complex fraction, try to simplify that first. Then when you simplify it, you can start seeing patterns. Ooh, potential inverse trig pattern, potential u sub. That's what I'm looking for there. Some u sub type stuff, inverse trig. All right, look for those patterns. Okay.